Biscayne High School.
Please enjoy the video.
Our first experiment was dropping a water droplet into some water. As you can see, the initial impact caused the ejecta to be thrown straight up. A process called refraction occurs when the initial impact causes the material to recoil and reject. This is where the water collapses and comes back down. This is the final step where the refraction process has ended.
This video is a prime example of how an object with more mass creates large ejecta. Since this is a lighter substance with a heavy object, the debris and ejecta spreads out further. This video shows how an object with a lighter mass on a heavier substance affects the ejecta and debris. There isn't very much ejecta like the rock and flour, but there is some you can see.
Here's the same experiment, but the ball has a heavier mass. We threw it at a 45-degree angle, and the ejecta was thrown mainly in that direction. This is the Tooting crater on Mars. You can see that the meteor hit the planet at an angle because of the direction the ejecta was dispersed.
This is the alluvial fan experiment. We tested how objects affected a water flow. The group found that the water works its way around the obstacles until there's enough force to move them. At first, the rock made a split in the river, but after it was moved away by the flow, it created an alluvial fan.
Here we try to replicate Jericho crater's alluvial fan, located on Mars. We poured water so it flowed into the crater, creating an alluvial fan.
This is a picture of the alluvial fan on Jericho's crater. As you can see, both fan out and change the surface in a similar way. This means that water may be the cause of Jericho's alluvial fan.
The group compared the alluvial fan in the Jezero crater to the Detroit Flats, which are 40 miles from their school. There, the water comes from the Santiam River rather quickly, then slows down due to the slope of the flats. In turn, this creates an alluvial fan.
Thank you for watching. Please follow our Instagram to see more of our videos.